See? Well, that's your fault then.
Here we go. Are you ready? Now, the parent function is the simplest form of a family of functions. We have many different families of functions. I'm going to show you a few of them today. The first one is y equals x. That is just mx plus b. Do you see that? It's just your lovely little line. It's mx plus b. The next one is y is equal to x squared. And this is what we call a parabola. It's my endless coffee or cereal bowl. Coffee cup or a cereal bowl. Okay? How do you spell that? P-A-R-A-B-O-L-A. Huh? Parabola. It's parabola. But it looks like it's parabola. Parabola. Okay. The next one is y is equal to x cubed. And this is what I call the cubic function, or it is the cubic function, but I call it spaghetti function. Because doesn't it look like a piece of cooked spaghetti thrown against the wall? No? No one agrees with me? I think it looks like a piece of spaghetti thrown up against a wall. But you'll remember the cubic function now, won't you? And the last one that you guys already know is y is equal to the absolute value of x. And what does that look like, folks? It looks like your v. Do we all understand that? It's your absolute value. These are your parent functions, folks. Okay? And the wonderful and beautiful thing about a parent function is what happens is they all have pretty much the same type of form. Okay? The only one that's kind of weird is the line, which we've talked about the line so unbelievably often, which is y equals mx plus b, right? But the other three have exactly the same form. And you already know that form. Y is equal to a, absolute value of x minus h, plus k for the absolute value. And instead of absolute value bars, we have what we call parentheses. And then I'm going to raise that to a power of n, where n is your power. And that power has to be greater than or equal to 2. Because if your power is 1, it's a line, isn't it? This is called your power function. Okay?
Oh, for the...
Yes. Or the 4th, or the 5th, or the 7th, or the 8th, or the 10th, or the 15th. Okay, those are all power functions.
And that's an n?
That is an n. Do you guys not like my n? Should I make it? Is that a better n?
So that would be the one with the...
Absolute value, or x squared, x cubed. Today, those ones are our x squared or x cubed. Okay? Alright, now, a transformation is a shift in a parent function. A translation is a vertical or horizontal transformation. Now, a transformation and translation sound very similar, right? A transformation is going to be a shift some way, somehow. Okay? They kind of are synonyms for each other, transformation and translation. Alright? Now, a vertical shift, this is very, very important, means you're going to add C units and it's going to put the thing up units. Anybody need a highlighter? Anyone? Anybody else? Okay. Now, if you're going plus C, you're moving it up C units. If you're going minus C, that means you're going to be going down C units. You're going to be going down C units. A horizontal shift. Horizontal shift means that it's going the opposite direction of what you think. Do you see that the x minus c you would think would go which direction? Left, but it's not. And we already know this because we already did absolute value of the vertex, remember? It's moving to the right. So this is not something new to you. This is something that you already know. If it's going plus c, we think it's going to the right, so the opposite of the right would be moving to the left. Yes, no? Are we all good with that? Okay. So we already know the vertical and the horizontal shift. Yes? We knew this from our lovely little equation that we had previously. Look at the parent function y equals x. That is this graph right here. Y equals X is this graph. Do we all see that? Now, compare it to the graph Y equals X minus 2. Now, if I'm comparing that to the graph Y equals 2, or Y equals X minus 2, what's happening to your Y values? When I'm at 0 here, I've gone to 0. When I'm at 1, I'm going to 1. Now let's compare them down here. When I'm at 0, I'm actually going to negative 2. Well, what's the difference between 0, 0 and 0, negative 2? The Y value has changed and went down 2 units, correct? Well, let's look at the 1. I go from 1, 1 to 1, 1, negative 1. Well, let's think about that again. My Y value went from 1 down to negative 1. How many units is there between them? 2 units, okay? So if you look at all these, every one of them is down 2 units. And I'm only looking at the Y values. The Y values are the ones that are changing. Do we all see that, yes or no? Great. So what this means is this is my K value, and my K value is down 2 units. Do we understand that? And I put D for down because I'm too lazy to write out the whole word. You may be that lazy also. So, this is actually 2 problems on there. Look at the first problem, Y equals X, and then Y equals X plus 5. What is different about those 2 graphs? I'm sorry? The 5. So what's happened to that graph? Here's what I want you to consider. I want you to consider having an XY table that is Velcro. And you're going to put on a line that is also the other part of the Velcro to make it stick to it, correct? So I'm going to pick up this line, Y equals X, and what am I going to do with it? If I have Y equals X and Y equals X plus 5, what's happening to it? What does that plus 5 mean? It's going up 5 units. So pretty much, the line itself has not changed one bit. I'm just placing it someplace else with on the Velcro coordinate plane. Agree? The place that I'm moving it is up 5 units. So what about this one over here? Now I have the line Y equals 3x. So I graph that line Y equals 3x, and I pulled it off the Velcro, and now what am I going to do with it? Move down. Move it down 10 units. Do we get that, yes or no? Make sense? Because they are exactly the same line, Y equals 3x and Y equals 3x, but now that minus 10 says that I just hold it down. Any questions over that? Excellent. Moving right along. Now compare the graphs of Y equals X squared. Here's Y equals X squared, and that is going to be this one right here that touches the origin. The parent function is always the one at the origin. And then the other graph is X squared plus 4. Well, graphically, what happened? It moved the entire thing. It took it off the Velcro, coordinate plane, pulled it off, and stuck it right up to value what? 4. So this thing moved up 4 units. And what can you tell about that graphically here? This column of Y values is going to be your X squared. This column of Y values is going to be your X squared plus 4. Check that out. They're all increased by how many units? 4 units every time. Makes sense. Excellent. Now, how are the following graphs related? Y equals 2x and Y equals 2x minus 3. They're exactly the same line.
They all go down 3?
But the 2x minus 3 is translated down 3 units. What about 5x cubed and 5x cubed minus 2? Same exact cubic spaghetti function, right? But now it's being moved down 2 units. Do we understand that, yes or no? Are we good with up and down? Great, because now we're going to go left and right. Now, we already did left and right with our lovely little absolute value graphs, correct? So again, how do I know which one is my parent function? What did I just say a minute ago?
Whatever one starts with the origin.
Whichever one touches the origin. So here we go. There's my origin. So that is going to be my lovely little absolute value of x. And now what is going to be my other one? The one that's off. In which direction did that line go? It went to the right. Now look at the equation. Y equals the absolute value of x minus 5. Why is it going to the right? Because it's subtracting, and we know that's the opposite, so I know it went to the right 5 units. Do we understand that, yes or no?
This overview.
Moving right along. How are the following graphs related? I have x squared and then x plus 2 quantity squared. It's going, it looks like, which direction? It looks like it's supposed to go to the right, but which way is it going to be going? It's going to go to the left 2 units. Do we understand that? Just 2 units. Okay? Now what about the second one? Y equals 5x cubed and y equals 5 times the quantity x minus 2 cubed. It's going to go to the right 2 units. Why is it going to the right? Because we think it's going to the left because it's minus, but that's the opposite, so it's going to the right 2 units. Do we understand? The graphs are still the same. It's still that lovely little Velcro concept. I pulled it off, but instead of going up or going down, I moved it to the right or to the left. Do we understand that, yes or no? Great. Because now what we have is our stretch and our compress. Okay? Now, let's say I have this lovely little rubber band. Okay? And if I take this rubber band between my 2 fingers and I say I want to stretch it, what happens to it?
It stretches.
It gets longer and what? Thinner. So I have it just like this on my thumb, and it's just this regular, normal, standard size, regular family of a function. Yes? As soon as I want to stretch it, it gets lean, right? It's pulled up. Make sense? So what this means is, if I stretch something, that means I'm multiplying it all by the y values of the function by the same factor greater than 1. It has to be greater than 1, because whenever you stretch something, you're stretching it twice as much, 3 times as much, 4 times as much. Do you see that? Yes? Because it's itself. A stretch means it's itself and then increased, right? Self and then increased. So that's why it has to be larger than 1. Do we all understand that, yes or no? Make sense? Okay? How would I describe this? It gets skinnier. It gets very skinny. Okay? And it gets closer to the y-axis. And whenever I say closer to the y-axis, I mean its arms. Okay? If I'm the parabola, you see my parabola, my arms are up there in the shape of the U. If I'm being multiplied by a factor of 3, somebody pushed them together, right? I pushed them together and I got closer up to the y-axis. Now, do we all understand that? So this is my standard family function. Now, if I want to change this, okay, the opposite of skinny would be what? Fatter or wider. The opposite of stretch would be a compression. Now, if it's not a whole number, what is it? It has to be a fraction, right? So what I want to do is I want to take this lovely fraction and I want to cut it, or this lovely function, I want to cut it. Before I can cut it, what do I have to do? I got to put it down, I got to actually cut it to open the arms up and actually make it wide. Because if I put it this way, I'm just stretching it again, aren't I? Yes? So you actually have to cut it, and you're going to have to make it wider. Do we all understand that? Okay? So when it's a fraction, it becomes a compression or a shrink. And that fraction is whenever a is going to be between 0 and 1. So that's the only time you're going to have a fraction is between the numbers 0 and 1. We have a fraction between the numbers 0 and 1. And this is what we call the compression factor. We have a stretch factor and a compression factor. If you use shrink instead of compression, I'm okay with that. Same concept. Now, when you stretch something, you're multiplying by a value larger than 1. When you compress something, you're multiplying by a value of smaller than 1 but larger than 0. The table represents the function f of x. G of x is a vertical stretch. Now, we just learned that. What's a vertical stretch? Multiplying by what? A stretch and a compression are both multiplication. The difference is a stretch is by a number larger than 1. A compression is by a fraction. Do we understand the difference? So I have a vertical stretch, where f of x is defined as g of x is equal to 3 times f of x. So this is a stretch. This is not a compress. Okay? Since it's not a compress, what am I going to do here to find my g of x function values? What am I going to do? This is going to be my g of x, and g of x is defined to be 3 times f of x. Well, guess what? My y value is my outcome of my f of x, isn't it? So what am I going to do to get my g of x values? I'm going to take all of my y values and multiply them by 3. Do we see that? I took every one of my y values for my f of x function and I multiplied it by 3. So what is 3 times 2? So I have 6 2 times. What's 3 times negative 3? And what's 3 times 1? And what's 3 times negative 2? Do we see that that's my g of x function? In other words, what you would have is negative 5, 0, 3, 5, and then 6, 6, negative 9, 3, negative 6. If I wanted to plot them, I would plot the point 5, negative 5, 6, negative 5, 6, 0, negative 9, 3, 3, 5, negative 6. Do we understand that? Great. Now what about this one? This is actually the same concept, except for if g of x is the vertical compression. Compression, what does that mean? It means you have a fraction this time. And g of x is defined to be 2/3 of f of x. G of x is defined to be 2/3 of g of x. So how do I find that out? 2/3 of f of x, sorry. No, not by the reciprocal. So I'm going to take every one of my f values, which is my y, okay, and I'm going to multiply them all by 2/3. Do we see that? Yes or no? So I'm going to have 2/3 times negative 2, 2/3 times 6, 2/3 times negative 12, 2/3 times 9, and 2/3 times 0. Now 2 times negative 2 is negative 4/3. 6 times 2 is 12 divided by 3 is 4. Negative 12 times 2 is negative 24. Divided by 3 is negative 8. 9 times 2 is 18. Divided by 3 is 6. Anything times 0 is 0. Do we see our g of x function there? Yes or no? Great. Now, here's what I want to know. Can you describe the transformation for these things? So let's look at f of x. I want to know what's happening to this thing. What does the 3 represent? Okay. What does the 2 do? On the inside, what does that negative 2 do? This moves it to the right 2 units. What's the negative 8 do? Moves it down 8 units. And now what does that lovely little 3 do?
Stretches it.
Stretches it by what? A factor of 3. So I have a stretch of 3 here. Do we see that, yes or no? Make sense? Okay, now look at g of x. Do exactly the same thing. So which way do you want to start? Where does your brain go to first? 2/3. What's happening with that 2/3? It would be a shrink because it's a fraction of 2/3. Then what? Going to the left, 6. Then what? I'm sorry? And a 5. Do we all understand that, yes or no? It's a very important thing. Notice that this is my parabola function, which is the squared, and then this was the cube function, which is going to be our spaghetti. Do you see those pictures in your mind? Do you see it? Okay. And then the last one that I want you to look at here. Next to last one, sorry. What's going on with this one?
Stretch by 6.
Stretch by 6. To the left 9. And down 2. Do we see that? Makes sense. Okay, last one on this slide. Now what? This is review. You should all know this.
To the right.
I'm going, so what does the 1/4 mean? I'm shrinking it. What does the -5 do?
You go right.
You're going to the right 5. What does the +8 do? Up 8. And now I want to know what in the world is going to do. What's that negative doing?
Negative doing.
No, we talked about this whenever we graphed our absolute value functions.
Oh, it's okay.
It flips it over what? It flips it upside down, which means, you know what we're going to call that today? We're going to call that a reflection. And more importantly, can you guys tell me what that reflects over? Which axis does it reflect over? The y-axis, which is the vertical one, or the horizontal one, which is the x-axis? It reflects it over the x-axis. Okay? Now, why is that? Very good. Because that leads us right into what we're doing right now, which is reflections. Reflections flips the graph of a function across a line such as the x or the y-axis. Now, here's the kicker. These are so crucial. Reflection of a function f of x over the x-axis. What in the world does that mean? If it's reflected over the x-axis, that means that you're taking the whole function and multiplying it by -1. You're taking the whole function and multiplying it by -1. Is that what we did in our last example? I did. That's exactly what we did in our last example. See, I have that -1/4 there. I multiplied the whole thing by a negative. Okay? Reflection over the y-axis, though, means that I'm doing f at -x. What in the world does that mean? Every place you see an x, instead of having x, you're replacing it with what value? -x, because that's what it means to evaluate a function, okay? That means you're doing plug and chug here. You are using plug and chug. And every place you see an x, you're going to replace it with -x. So every place I see an x, I replace with -x. That's what it means to be a reflection over the y-axis. Okay? Now, let's think about this using points. Now, there are 2 problems here. Do you all understand that? We have problem 1, which is -1, 2, and problem 2, 6, -7. I put them on one order pair for you, on one graph for you. Now, I want to reflect the point -1, 2 over the y-axis. If I reflect that over the y-axis, I want you to consider back in grade school. You put a blotch of paint on a piece of paper and then you fold it, right? And that paint blotch went someplace else across that fold, correct? That's exactly what we're doing here. If it's across that fold, you guys tell me, what are we doing?
Having a dilemma and being a settlement.
Okay, now if I'm reflecting this over the y-axis, where does that paint blotch end up at? On the other side, where?
+1.
+1, 2. Now let's think about that. remember, when it's over the y-axis, what happens when it's over the y-axis? Every place you see an x, you replace it with negative x. Is that what we did? This was negative 1, so it turned into positive 1, because a negative times a negative is a. Does that make sense? Okay? Now, what do I want to do whenever I replace it over the x-axis? What happens there? Where's that going to go over here? According to my paint blotch, which is at negative 1, 2, where is my paint blotch going to end up at if I reflect over the line y equals, or the x-axis, sorry. Where is this going to go if I fold it over the x-axis? Oh, negative 1, negative 2, which puts me right there. So what changed this time? It said I was distributing a negative into it, which means my y value is the only one that changes on that. Does that make sense? Was my y value the only one that changed? Absolutely. Now how about the next one? 6, negative 7. If I am reflecting it over the x-axis, putting it hamburger style, which one changes? Does the x or the y change?
The y.
The y changes, so I'm still at 6, but I'm going to go up from here, positive 7. Because it says up there that the only one that changes is the y coordinate, right? Now, if I'm still going to take this point, 6, negative 7, and I'm reflecting it over the y-axis, hot dog style, which one changes?
X.
The x changes because every place I see an x, I change that to the opposite sign. So that's going to be negative 6, negative 7. Do we understand this whole concept of reflecting over the x-axis and the y-axis, and which one changes and when and why? Yes? Because what you have to be able to do now is you have to come up with a new function g given a function f. So the function that I give you is 3x plus 3. So I want to be able to find the function g of x, which is a reflection over the y-axis. So if it's a reflection over the y-axis, you guys tell me, what did we just write over there? F at negative x. So g of x is the same thing as f at negative x. So every place I see an x, what am I plugging in? F of x is 3x plus 3. So I'm going to plug in the negative x. So 3 times negative x gives me negative 3x plus 3. That's my g of x function. Do we see that, yes or no? Does that make sense? Okay? Because now I have a new function. I have a new function, f of x, 2x minus 1, and now I want to find g of x again, but this time it's going to be a reflection over the x-axis. And what did we learn about whenever we did our points on the x-axis? Do we replace or distribute? You distribute, so this is going to be negative f of x. Do we see that, yes or no? So now my g of x is going to be negative times f of x. And what is f of x? 2x minus 1. Do we see that? Yes or no? G of x, because it's a reflection of x over the x-axis, says that's equal to negative f of x. So this is going to be negative 2x plus 1. Do we see that, yes or no?
So you have to put the reflection of f of x of that x-axis. You have to make sure you put the g of x equals the negative.
All you have to remember, don't make it difficult. When it's over the y-axis, you replace x with negative x. When it's over the x-axis, you distribute a negative into the function. That's it. Okay? When it's reflected over the y-axis, you replace x with negative x. When it's reflected over the x-axis, you distribute a negative to the whole thing. That's it. Okay? Now, this is combining two functions together. The graph of g of x is the graph of f of x equals 4x, compressed vertically by a factor of 1/2, and then reflected over the line the y-axis. What is the function rule for g of x? So what we're doing is coming up with a function rule. So we don't have to play with that f of x function. So if I want to reflect this thing, which one do you want to do? Do you want to compress or do you want to reflect first? It doesn't matter. First one. Let's compress it. So when you compress, what are you actually doing? When you compress, what are you doing? You're multiplying by a fraction. And what is my fraction I'm multiplying by? 1/2. So what I'm going to have here is 1/2 times my function, which is 4x. So what's 1/2 times 4x? 2x. And then it's reflected over the y-axis. So if it's reflected over the y-axis, what's that mean you do? You replace it with a negative. So that means now I have to do f at negative x. So that's 2 times negative x, which is going to be negative 2x. There's your function. Do we understand that? Yes or no? The graph of g of x is the graph of f of x equals 2x stretched vertically by the factor of 5. So what does that mean? That's going to be 5 times 2x to give me what? 10x. So I have now stretched this thing. Right? Now what else do I need to do? And then reflect it over the x-axis. So if I'm reflecting over the x-axis, what do? I distribute. So now I'm going to do a negative times f of x, which is negative 10x. So g of x is negative 10x. Do we see that, yes or no?
That's the one from left.
What transformation changed the graph of f of x to the graph of g of x? So what do you think happened? How did I get the 2x to change into a 6x? What did I do? I multiplied by 3, so I have a stretch of 3 to get the 6x. And then what did I do with the minus 1? How did I get that? And then I moved down 1 unit. So I took f and I stretched it by 3, and then I moved it down 1 unit. Do we see that? Now, determine all the transformations. I'll pass out your homework as you guys do number 1 here. Because this is the key part. This is the whole reason that we do all this. If you got it was reflected over the x-axis, you're right because that's negative. If you said it was a stretch of 6, you're right because it's a whole number larger than 1. If you said it went to the left 9 units, you're correct because it's opposite of what you think it is. And if you said it went down 2 units, you were correct because it is exactly what you see minus 2. How many of you got that? Good job. Did you understand? Okay, tonight for homework, you guys owe me this worksheet. Now, problems 1 and 2, it says, how is each graph related to y equals x? So I'm looking for up, down, left, right. Problems 3 through 5. It says, make a table of values for f of x after the given translation. So this says it's going to go up 2 units. So you're going to take f of x and do what to it? Take the y value and add 2 units to it, right? take the y value on number 4 and do what to it? You're going to add 3 units to that. Sorry, number 2, you're going to subtract 2 units. I'm sorry, I said the wrong direction. And number 5, 1 unit down, what are you going to do? You're going to subtract 1. Now, number 6 and 7, it says write an equation for each vertical translation. 1/4 unit down. It's giving you just f of x. We don't care what f of x is. All I want to know is what's going to happen to that parent function if it does 1/4 of that. Okay? So tomorrow we'll go over any questions that you have over this. Have a great day, guys.